Hello.
Yes, sir.
Hello. Whether voice is audible?
Yes.
So where we were in last lecture? Syllabus discussion was going on. No? Okay. So in last lecture we have started. Syllabus discussion was over and some basic things we have discussed. Okay. So what is the name of our subject? So I have told. So you have to see immediately slides. Then you can understand which things we have to learn. What is the name of our subject?
Engineering
Engineering mechanics.
Engineering
mechanics.
Okay. From tomorrow, you need a calculator. Okay. So from tomorrow we will start problem solving also. So whatever theoretical part will be there, that we will complete today. With the beginning, those who have missed the first few lectures, for them I will revise quickly what we have seen in last lecture. So as per syllabus, we have seen this subject is divided into two sections, section 1, section 2. There are 4 chapters in each section. What famously first section is known as? What we are calling to first section?
Statics.
Statics. And second section is dynamics.
Dynamics.
Okay. We have definition. Those who were absent, they can see what we have seen in last lecture. Okay. So, and this. So we have started with the mechanics, engineering mechanics, then statics. We have seen dynamics, again 2 parts of dynamics. Okay, that we have seen. So further it is going to come. Syllabus, we have discussed actually what will be the syllabus for chapter number 1, which things we are going to study in this. Okay, that we have seen. Syllabus is in front of you. So basic things are required. So how to calculate force, moment, etc. That things are going to come. So that syllabus is in front of you. That we have seen. Further, we have seen resultant. Okay. About the title of chapter. So in this, resultant of coplanar forces is the title of our chapter. Here we are going to see the resultant and resolution. These two terms I have discussed with you. What is a resultant and what is a resolution? Okay. Resultant means what? Resultant means what? So before that, in that it is given force. What is force? Force is an external agency which changes the state of body. That we have seen. Coplanar forces. What example I have given to understand the meaning of coplanar forces? The terminology beginning with point, okay, line, then plane, then solid. How it is that we have seen. Okay, so in this only about title of chapter, what we can, in which the resultant of coplanar forces, what we are going to see in this chapter, it is given, it is very basic chapter from our syllabus. This chapter is most important in the syllabus. Okay, force definition also we are going to see which are the important thing in the force. Then here it is coplanar force. The definition we have discussed. What is coplanar force? Whenever I'm going to utter the word coplanar, so you should remember immediately. Coplanar means plane of we can say your notebook, and whatever lines you will draw on that page, it will become an example of coplanar forces. It is as simple as this. Central idea, what we are going to see in this chapter, it is nothing but central idea. So which things we are going to see here? Okay. we will see further. Then concurrent and non-concurrent forces. So while discussing this thing, concurrent and non-concurrent forces, what we have to understand, or which thing we have to keep in mind as far as force is concerned, its line of action. Means either we have to extend that force and we have to check whether given number of forces are passing through one point. If line of action of forces will pass through one point, what we have to call it as?
Concurrent force.
Concurrent force.
Concurrent forces. We have to call it as concurrent forces. And if whatever number of forces are available in a system, and if at all we are going to extend a line of action of that force, line of action means only line. So arrow is shown. That also you have to see. So whatever arrow is shown for the line, whatever arrow is shown for the line, only we have to extend that arrow. Suppose for this force, if at all I am going to extend this, so it will be same force here, even at the back side also. Whatever line of action I am going to extend, I have to show something like this. Okay, so this will be the line of action of this force F. So here already I have given. So in this way, we have to just extend line of action of that force, then we can realize. Okay, whatever line of action. So if we are going to extend line of action of force, and if it is going to pass through one point, we are going to call it as concurrent force. If not, we are going to call it as non-concurrent forces. Okay. Further importance of chapter, why we should study. We should have a basic knowledge of forces, how composition is going on, resolution is going on, that we have seen. Then this thing we have seen, chapter outcome, what it means. Chapter outcome means at the end of chapter what we should study, or what should be our output as far as this chapter is concerned. Student will understand fundamental concepts of statics, because this one is the first chapter from statics. Okay, student will able to apply different laws related to composition of forces. Student will understand the concept of finding of resultant of forces. Okay, that way. Core syllabus, here it is starting core syllabus. What we are going to study in the mechanics, force and its effect. So which one sentence I have told as far as engineering mechanics is concerned, if something is not there, we cannot study mechanics. What was that?
Force.
Unless and until there is no force, there is no mechanics. Means here force and its effect on the body. So without force, this subject will not be there. So force should be there to study this subject. Okay, so mechanics is the branch of physical science we have seen, which deals with the study of forces and their effect on the body. Further, it is divided into two parts. Many of the students were absent for first few lectures. For them, it is a revision quickly. So we have seen mechanics. There are two types. Mechanics is divided into mainly two parts. One is statics, another one is dynamics. In statics, only we have to remember, anyhow we are going to study forces and their effect. And in statics, that body will be at the rest. And what will happen in the statics? In dynamics, body will be in motion. Body will be in motion. Those who are absent, they should keep in mind. They should write in their notebook. So here it is mentioned, body should be in motion. Okay, in this way, body should be in motion in dynamics. Further, there are two types of dynamics. Which are they? Further, dynamics is divided into two parts. Which are they? Kinetics and
Kinematics.
kinetics and kinematics. What is happening in kinematics, or what is kinetics? Here we are, what we are going to consider. It is a branch of dynamics. What we are going to consider, which two things? One is mass of the body.
Mass and force.
of the body and force.
Another one is forces, which cause the motion. That we are going to consider in kinetics. Okay, and in kinematics, we are not going to consider mass. We are not going to consider mass and the forces which cause the motion. So quickly, mechanics divided into two parts, static and dynamics. Dynamics further divided into two parts, kinetics and kinematics. In kinetics, we are going to consider mass and force which cause the motion, and on the other hand, in kinematics, we are not going to consider mass
and force causes motion,
which cause the motion. So here in chart it is shown how it is. So mechanics, so blue colored mechanics, then further it is divided, but what we are going to consider, rigid body. This further it is going to study in higher classes, especially for civil and mechanical engineering. It is there, but right now what we are going to see, mechanics Mechanics of rigid body, statics, dynamics. Further, dynamics is divided into two parts. So whatever summary we can say, from here it is started, then here in this way. Okay, again further two parts and two parts of dynamics in this way. So it is just a summary type. It is shown in by the chart. It is just shown by the summary. Okay. I have drawn on the screen. Is it possible for you to see? Just check. Yes. Okay. Okay. In this way, it is divided further. Statics and dynamics. A simple example is given. In dynamics, body is in motion. That is your alternative. So, which is this example? What is this? In last lecture, I have told what is this?
Part
Part of engine.
Part of engine. But what is the name of that part?
Piston and cylinder.
Piston and cylinder. We have seen this because once we will start a two-wheeler, what will happen? Once we are going to start two-wheeler, that piston and cylinder arrangement will go in oscillation motion, to and fro, something like that. You might have heard the word compression and expansion. Okay, there is it is a part of actually IC engine. IC means internal combustion engine. A cylinder is something like this, and here there is a piston, something like this. No, here it is a piston. You will come to know that. Okay, this maybe in your basic mechanical engineering, and this piston is moving, or it is making oscillatory motion, maybe to and fro in this way. Okay, so compression and expansion will happen of air, fuel mixture, etc. You will come to know that. But what is our what we have to see here? It is making continuous movement. Okay, that's why it is it will fall under dynamics and statics. Statics. What is statics? A branch of mechanics. What we have to consider in statics?
The body at rest.
Body is at rest. That is statics. That we have discussed. Further basic concepts we have seen. What is basic concepts? Body. What is body? An object. So meanwhile you have to write. Either you have to write or take the screenshot. It should be there in your notebook. This slide should be there. If it is not there, this slide, if at all it is not there, no worry. Statics and dynamics. Okay, it is just for information. But this slide, it should be there in your notebook. For example, body, an object which has definite mass, which occupies definite space, it's called body. Further, it is divided into three parts that we have discussed. One is rigid body, another one is elastic, and one more we have discussed. What was that?
Plastic body.
Plastic body.
It was a plastic. Okay, rigid, a body which does not undergo any change in dimensions or shape after the application of external force is called rigid body. So actually we have discussed that this type of body is what kind of body? It is
Ideal.
ideal, because there is no such body, because anyhow whenever we are going to apply force, it will go under some, or anyhow it will go under deformation. So it is called as rigid body. Elastic, once we are going to remove its whatever force is applied, that body will regain its original size and shape. It is called as what type of body? Elastic body.
Elastic body.
Elastic. Further, just we have discussed one more. It was a plastic body. What was that plastic body? Once we are going to apply the force, and once we will remove that force, whether body will get its original shape and size?
No.
No.
Example we have seen, mud is the example of plastic body. Further, this we will see. Okay, elastic body, plastic body, and rigid body. There is some internet issue. Which thing you are observing on the screen?
Three basic
Three
types
basic
of
types
rigid
of
body.
rigid motion.
Body motions. That motions we are going to see further. Before that, we have to cover. My slide is not changing. Just wait. There is some internet issue, I think. Okay, I think it is changed. Basic concepts in that again: displacement, velocity, acceleration, and distance. Whether these terms we have discussed: displacement, velocity, acceleration, and distance.
Yes, sir.
Displacement is what? Scalar quantity or vector quantity?
Displacement is vector quantity.
Vector quantity.
Displacement is vector quantity. So such questions you have to keep in your mind. So displacement, the distance moved by body or a particle in specific direction. Specific direction is called as displacement. Okay, velocity. The rate of change of displacement with respect to time is known as velocity. Velocity is scalar or vector?
Vector.
Vector quantity.
It is vector. Acceleration, am I audible? Just check. Acceleration is
The rate of
Rate of change of velocity with respect to
time. Is it scalar or vector quantity?
Vector.
Vector quantity.
Distance. It is a numerical description of how far the object is located. It is as simple as this. It is the numerical description how far is the object is located. Okay, it is also defined as the length of specific path traveled between 2 points that we have seen. Distance is scalar or vector?
Scalar quantity.
scalar.
Again scalar. Next one is speed. Speed, is it a scalar or vector? Speed.
Scalar.
Scalar.
The rate of change of distance with respect to time is called as speed. Speed is scalar while velocity is vector, as you know better. Momentum. Okay, the product of mass and velocity is known as momentum. Okay, so here, meanwhile, while discussing last lecture, I have discussed one more term related something like this. Momentum. Are you remembering which term I have discussed here? So I have written that somewhere something.
couple movement.
Okay, correct. Somebody has given correct answer. Couple or moment. What was that? Are you remembering?
Movement of
Rotational effect.
Very good. Those who are remembering, very good. Moment we have discussed. It is nothing but the rotational effect. Okay, it is nothing but rotational effect. Moment is equal to force into perpendicular distance. Force into perpendicular distance. You remember this. Afterwards, we are going, because many more problems we are going to solve on this. So that will come in further. Okay. Meanwhile, momentum is nothing but mass into velocity. Then scalar quantity and vector quantity. We have discussed the physical quantity which can be completely described only by magnitude. Okay, it is called as scalar quantity.
Scalar quantity.
Physical quantity which needs magnitude as well as direction. It is called vector quantity. It is basic, as we know. Okay. Force, action of body onto the other body, push or pull, something. Okay, so whenever we want to describe the force, which things are important? Point of application, where it is applied, direction, in which direction force is applied, and how much it is applied. Okay. Okay, point of application means whenever we want to describe a force, these things are required. This thing, point of application, where it is applied, in which direction force is applied, and how much its magnitude, that it is required. So in this slide, it is not necessary to write this slide, definition and features. So this slide is not necessary to have in your notebook, but this terminology, 11 terminologies, it should be there in your notebook. Okay. Mechanics, when mechanics will come into picture. So example, it was shown. So though we feel a car is moving on the road, so number of forces we have discussed will come into picture. Okay, so all the forces in last lecture I have told, the weight of the car, the force, air force applied on the car, the power generated by the engine which will force car to move in forward direction. That one is also the gravitational weight of the car which will be vertically downward, the reaction offered by wheels at the end of wheel, that will be one kind of force. So in first picture, if at all only you are observing car is moving from on the road, if at all you are going to observe in first picture here, a car is moving on the road. Okay, just it is passing on the road, but which type of forces will come into picture? It is nothing but many more forces. Here you can see forces are going to come into picture, and this study of all these forces is nothing but what? Study of all these forces is nothing but what?
Mechanics.
Is nothing.
Mechanics.
is nothing but mechanics. Okay, so that we have discussed. Not necessary, it is for your information. Not necessary to draw diagram, write in your notebook. It is for your information. Further, few types of forces here it is shown. Concurrent and non-concurrent forces already we have discussed. Concurrent force means what? So here you can see. So this also we have discussed. So not necessary to draw diagram. So how many forces are there? Here I have made one circle. How many forces are there which you are observing?
4.
4.
Why we should call it as a concurrent forces?
Because line of action passing through common point.
Line of action of all forces. Okay, that should be your correct sentence. Line of action of all forces is passing from where?
Common point.
Same point, common point.
Same point or common point, or one point we can say. Line of action of all the forces is passing from one point or single point. More specific word is single point. It is passing from single point. That's why it is called as concurrent forces. Non-concurrent, opposite to it. Okay. So if line of action of forces is not passing from single point, non-concurrent forces. Further, collinear forces. If line of action of forces will pass only from one line, it is something like that. Which is this activity? I have given example. Which is this activity?
Tug of war.
Tug of war. So whenever you are going to pull the rope, whenever you are going to pull the rope, it is called as all the forces, line of action of all the forces will pass through a single line. It is called as collinear forces. Okay, that one is example, tug of war. So whatever forces will be there in that, it will be collinear forces. Okay, non-concurrent, non-coplanar forces. So coplanar forces means what? What we have discussed. The coplanar forces means what? Coplanar forces means what? Line of action of forces will be where in coplanar forces? Am I audible?
Yes, sir.
Yes, sir.
Coplanar forces. What is coplanar forces? Line of action of forces will be in one plane. Whether it is correct, line of action of force will be in one plane.
Yes, sir.
Yes,
Sir.
Yes, sir.
Then non-coplanar forces. Non-coplanar forces means what? Line of action of force is not in one plane. Line of action of force is not one plane. It is called as non-coplanar forces. For example, suppose you will take example of tripod. So have you seen tripod where camera is fit for recording purpose? Something it is having, what we can say, okay. Have you seen tripod? Sorry.
Yes, sir.
Tripod. So whatever the forces are there, so you can see here there is one rope. Actually in fourth diagram there is one rope. With this rope that JCB is just lifted up to certain height. Are you observing? So here it is better. So you can zoom it in your mobile. So this diagram. So whatever forces will be there in that rope, it will be non-coplanar. Are you getting meaning of non-coplanar? Something like tripod. Tripod means it is having three legs. We can see in very simple language. So whatever forces are there in that three legs, it is non-coplanar. Or example, another example you can take. Example of suppose chair or table. How many legs it is having? Chair, or we can say table, 4, no? So whatever are there on that leg of that chair or table, so whether it will be coplanar or non-coplanar, whether that all will be in coplanar fashion or non-coplanar fashion, I think some of the students are not getting meaning of coplanar. Okay, so coplanar means what? This is one plane and forces are there perpendicular to this. Suppose perpendicular, perpendicular, perpendicular in this way. You might be observing perpendicular. Okay, in this way. Okay, so whether we have to call whatever perpendicular to this forces are there, is it in one plane? Can we call like this? एका प्लेन मध्ये आहेत असं म्हणूया का आपण?
Yes, sir.
Yes, sir.
Whether we have to call it is what definition I have given for coplanar forces?
Line of action of
Line of
force.
action of
Line of action of forces on a single plane.
सिंगल प्लेन, मग हे सिंगल प्लेन मध्ये येतील का? त्याच्या लाईन ऑफ ऍक्शन आपण ड्रॉ करतो, याच्या व्हर्टिकल यायला लागल्या, अशा व्हर्टिकल 1 2 3 4 लाईक दिस.
Yes, sir.
एका प्लेन मध्ये येतील लाईन ऑफ ऍक्शन
No, sir.
येतील का?
No, sir.
No,
No,
sir.
sir. No, sir.
Or in whatever line of actions are there of the force, whether one plane is passing from that line of action of force, not. That's why it is non-coplanar. इथे का लक्षात बघा. If we are going to pass one page through line of action of forces, then it is, we can call it as a coplanar forces. If not, we have to call it as non-coplanar forces. Suppose you will imagine there is a ground. On ground, number of trees are there, and suppose each tree has a one force. So is it possible to pass one page through that all trees, whatever trees are available on the ground? एका प्लेन मध्ये बसू शकतील का? म्हणजे पानासारखं प्लेन घेतलं. If we will take one single page where we can pass a line of action of all that trees, if we will consider trees as a force, it will not possible. हे possible होऊ शकत नाही. That's why it is an example of non-coplanar. I have given long back example of coplanar forces. If you will take one page in your hand and if you will draw number of lines on that page, so all the line of actions are remaining in one page. Okay, so that's why it is called as coplanar forces. So little imagination is required. Coplanar and non-coplanar. So best example I have given of page. Okay. Then prerequisites. Prerequisites means what? To learn this subject. To learn this subject, which basic things are required? Prerequisites means what? Basic things. So scalar and vector quantity, nothing to discuss about this. Okay. We know better what is scalar quantity, what is vector quantity, to whom we should call as scalar quantity, to whom we should call it as vector quantity. Okay. Further, Newton's laws of motion that we will see. Then law of conservation of momentum. So you might have heard this. Newton's law of gravitation. This might be knowing equations of motion. So these are prerequisite. Prerequisite means what? Basics. You know this. Just you have to revise to understand further concept. What is prerequisite means what? Prerequisite means what? It is a basic things which you have learned, but still we have to revise it. That's why. So scalar quantity and vector quantity already we have discussed. So which are the scalar? Even I have asked for each definition whether it is scalar, whether it is vector in that way. So what is scalar? What is vector? That also you know. Now let us go. Next one is, what is this? What you are observing on the screen?
Newton's
Newton's
law.
law of motion.
Newton's
first law of
law of
motion.
motion.
Okay. So Newton's first law of motion. Can anybody tell statement of that? So it is not on the screen right now. Can anybody? Is it possible? Have you studied before this Newton's law of motion? Have you studied before this, or have you came across before, maybe in your 11th, 12th, 10th, 9th class somewhere? Say yes, either yes or no. If not, I will show next slide. Either then.
Yes, sir.
Yes. And what is the statement? If you have come across Newton's first law, then what is its statement?
An object will not change its motion unless acted on by an unbalanced force.
Very good. The object will not change its what? Will not change its
Motion.
motion. So instead of motion, which will be correct word? The object will not change its, instead of
Uniform.
Position.
uniform motion.
Position.
Position. Correct. I want, you are near. You are near. Instead of position, instead of motion.
State of rest.
Correct. What is that?
At rest.
State of rest.
State of rest. State of rest.
Rest.
Okay, you are saying state of rest. More precisely, more clearly, we can say this. Okay, instead of that, we can say state of the body. State of the body means how will be the body. Every body continues in its state of rest or of uniform motion in a straight line unless it is acted upon by an external unbalanced force. Okay, everybody continues in its state of rest or uniform motion in a straight line unless it is acted upon by an external unbalanced force. Who will explain this? Now the statement is in front of you. What Newton's first law of motion saying? Or which thing we can define from this? From the first law of motion, which things we can define? Or what it describe? What happened? Is it last lecture or you are not understanding anything? What it defines? Or I will ask simple, which property of object this first law of motion is defining? Object ची कुठली property हा law describe करतो? Which property of the object it describe? म्हणजे तुम्ही बसलेला आहात, तुम्हाला पुढेच जाऊ वाटत नाही का? कुठं कधीपर्यंत जाऊ वाटत नाही जोपर्यंत तुम्हाला फोर्स लावला जात नाही. So what this property is called?
If you don't apply the unbalanced force to the object which is initially at rest, then that object will never change the position of that object.
Okay, correct. You have explained the correct, but what is this property of object? What we are calling? कुठल्या object ची property? Means you are at the rest. तुम्हाला पुढेच जाऊ वाटत नाही. Why? Unless and until there is no force. Or suppose you are in motion, you want to be continue in motion. You don't want to stop. Which is what it is called? त्या प्रॉपर्टीला काय म्हटलं जातं फिजिक्स मध्ये? What we are calling in physics for this property? What it is? Huh?
At rest.
At rest. What it is called?
Inertia.
What it is called? Have you heard this word or this property?
Yes, sir.
Yes, sir.
Have you heard?
Yes, sir.
What is it? In what respect you have heard this?
Inertia.
Inertia. What is inertia? What is inertia? In Marathi, at least you tell in Marathi what to call, to whom we should call inertia. Inertia कशाला म्हणायचं? मराठीमध्ये काय म्हणतात इनर्शियाला?
जडत्व.
व्हेरी गुड. जडत्व म्हणतो आपण, अंगात जडत्व आलंय का? समथिंग लाईक दिस. सो व्हॉट इज इनर्शिया? डेफिनेशन ऑफ इनर्शिया. Example you might have seen. Example you might have seen. Suppose you are traveling in a bus and you are sitting in one of the seat. Okay, and once the driver will apply brakes, what will happen? तुम्हाला काय होतं? Suppose driver will apply sudden brakes. I will use correct word, sudden brake. You will go in forward direction. Okay, जाता का असं एकदम ड्रायव्हरनं ब्रेक दाबल्यावर?
Yes, sir.
कशामुळं? Why it is happening so?
Force apply.
Not due to force apply.
Due to inertia.
Due to inertia.
What exactly happening there?
Friction.
Friction? No friction.
Due to opposite force.
Due to opposite force. Okay, partially correct. Due to opposite force. But what happens once you are suppose you are standing on one of the stop, you are stationary, correct? Very simple, very from the basic I will tell. You have there at one of the stop, ST bus came. You have just taken one of the seat in ST started with certain speed. You have occupied suppose one of the seat in the ST, correct? Once you will sit in the ST, you will take a speed or velocity, we can say velocity of ST, and your velocity will become one and the same. And after that, once you will get the velocity of the ST bus and driver will apply suddenly brake. Once driver will apply suddenly brake, that ST will stop. Okay, ST bus will stop, but you will continue in your motion for a while, not continuously. For a while, you will continue your motion. That's why you are going a little just you are going little forward direction. That is nothing but the inertia. That is nothing but the inertia. On the other hand, opposite is also possible. Suppose you are there in the car. You are just seated in the car. Car is stationary. You are just sitting in one of the seat of the car. And car is started suddenly. काय होतं? कार लगेच चालू जर्क झाला कारला. कार लगेच सडनली चालू झाली. What will happen? You will go backward. तुम्ही मागे जाता का पुढे जाता? तुम्ही कार मध्ये बसलेला आहात. कार एकदम सुरू झाली. Whether you will go backside or forward?
Backside.
Backside.
आता पुढे का गेला नाही? In that case, why you are going towards backside? का? तुमची which is your first state? Stationary or whether it was in motion?
Stationary.
Stationary.
Who is started having who got speed? Speed कोणाला मिळालं? कारला. त्याच्यामुळे कार पुढे चालली आणि आपण काय होतो?
Backside.
Back मागे जातो.
We were at stationary position. We were at a stationary position. That's why we are just going backside. Just going backside. Okay, that's why it is happening. Means what is this? It is called inertia. It is called inertia. ज्याला मराठीत काय म्हणतात त्यांना माहित नाही. For them also we will write. It is called मराठी मध्ये याला म्हटलं जातं जडत्व. आता हेतला अजून एक्सप्लेन कसं करायचं बघा. या लॉ न आपण इनर्शिया डिफाइन करतो बॉडीचं. मीन्स बॉडी विल नॉट चेंज इट्स मोशन. एखादी बॉडीला मोशन चेंज करू वाटत नाही. Or instead of motion I will say state. The body don't want to change its state. So that's why here I have mentioned this word. The body don't want to change its state. Up to where? कुठपर्यंत त्याला चेंज करू वाटत नाही. Up to where? Unless it is acted upon external unbalanced force. जोपर्यंत एखादा फोर्स अप्लाय होत नाही बॉडीवरती तोपर्यंत बॉडीला स्टेट चेंज करू वाटत नाही. That is called as inertia. What is opposition to motion? In simple words we can call it as a inertia. So everybody, that's why it is written. So once again you read carefully this statement. Every body continues in its state of rest or of uniform motion. Rest or motion. Everybody wants to be in rest or in motion unless it is acted upon external unbalanced force. Okay, it is. And what it defines? या फर्स्ट लॉ मधून आपण काय डिफाइन करतो? इनर्शिया. सो फॉर मल्टिपल चॉइस ऑफ क्वेश्चन इट इज इम्पॉर्टंट what we can define or which property of the body can be defined in first law, Newton's first law of motion. 1 2 3 4 force, maybe moment, inertia or some other. So what will be your correct answer in that case? What it defines? काय डिफाइन होते इथं?
Inertia.
Inertia.
So I feel you have heard this word, this term today. So you can Google it. Inertia. What is inertia of the body? You can Google it. You will learn many more things related to inertia. Inertia means what? Everybody want to be continuous its state, irrespective of it. It may be in rest position or it may be in motion. It want to be continue as it is unless and until it is applied by external unbalanced force. That one is first one. Here examples are given. So have you noted down this first law?
No, sir.
So either you can take screenshot or you can write in your notebook, and below this first law, Newton's first law of motion will define inertia property of the object. Likewise, it is important for multiple choice question. Likewise. So here first law, any problem? So it is basic.
No, sir.
It is not the actually
No, sir.
part of syllabus. It is basic. Just we are revising the things which you have learned in your 12th. Actual part we are going to see further. Here an object is at rest or object in motion stays in motion with the same speed and in same direction unless it is acted upon by unbalanced force. Means even here you can take example. Suppose you are a sport, you are having good knowledge of sport. Here football, in second picture it is football. Suppose it is a stationary. Why that football want to be moved from one place to other place? तो जाईल का मनाने जाईल का तो? Whether it will go on its own from one place to other. So here it is there, football, whatever it is there. So unless and until we will not kick it, once we are going to apply kick, then it will go from this to this and again this to this in this way. On the other hand, so example of suppose cricket. Once a bowler is going to throw a ball, or once he is going to make bowling, we can say something like this. Okay, and if batsman will just touch a ball, so that ball will get, what will happen? Either suppose, or it is having just a plate, suppose simple plate, ball will stop after some time in that way. So instead of that, here example is given is an object is at rest. Here example is given, a object is at rest. It is acted upon by a balanced force, stays at rest. Means in first example, what it is explained, first how it is explained, one body is there, it is at the rest. Here balanced force is applied. In this case, whether body will move, in this case, second case, equal force is applied from both sides. Whether body will move?
No.
No.
But when
No.
unbalanced force, why it is becoming unbalanced in third case? Why it is becoming unbalanced in third case? Because
Body is moved.
unbalanced means whatever force was applied, it is applied from one side only. It will become unbalanced and body will start to move. So that's why example is given. It will move in this way. Okay. So these are just an example. Next one is second, Newton's second law of motion. The rate of change of momentum is directly proportional to the applied force, and the change takes place in the direction of applied force. Okay, F is equal to ma. So meanwhile, just you can note down this: the rate of change of momentum is directly proportional to the applied force, and the change takes place in the direction of applied force. So what it defines? The rate of, have you noted down? Just check. The rate of change of momentum is directly proportional to the applied force, and further we are going to discuss these things. Meanwhile, you can see, so Newton's first law, Newton's second law. The rate of change of momentum is directly proportional to the applied force, and the change takes place in the direction of applied force. So here, if the same force is applied to an object with greater mass, the object accelerates at slower rate because mass adds inertia. Because mass adds inertia. More the mass, what will be its effect on motion? एखाद्या मास मध्ये जर जास्त एखाद्या ऑब्जेक्ट मध्ये जास्त मास असेल, if we are going to put more mass in object, with what will be the effect on its motion? इथे दाखवले बघा. In first tray there is one only block, we can say. So here there is only one block. एकच block आहे. Here number of blocks are available, and same person is pushing that particular tray. Okay, so which will be easy to push for that particular person? कुठला सोपा आहे ढकलायला पुढं? In which case, first or second?
First.
First.
So if the same force is applied to an object with greater mass, the object accelerate at slower. म्हणजे काय म्हटलंय बघा, same force is same. In both cases force is same. And greater the mass, जिथं mass जास्त आहे, greater the mass, the object accelerate at slower. Now this accelerate slower. Because कशामुळे होतं हे असं? Why it is happening? Why it is happening? Because here reason is given.
Mass is adding.
Mass adds.
Mass adds. And which property we have seen? Once more the mass, more will be the inertia. More will be the inertia. Something like this. Okay. Same example. More the mass, more force is required. Same example is shown here. 400 kg mass, more force is required to push it. On the other hand, 40 kg less mass. Okay, so you can see, just it is example. It is shown for an example. Newton's second law. Third one. Third one, what is the statement of third law? Anybody is remembering? So let me know. Anybody is remembering? What is third law? Are you remembering this or not?
Every action has a equal
Every
and
action,
opposite action.
Every action there is an equal and opposite
reaction.
reaction. For every action we can say there is equal and opposite reaction. Most important. This law is most important in our further syllabus. This law is most important. For every action there is equal and opposite reaction. हे ऐकलेलं आहे का? असं वाटतंय I am going little means speed up because already these things are known to you. Just we are revising the things. हे माहित आहेत ना गोष्टी? You can
Yes, sir.
Yes, sir.
these things are known to you. That's why example of these things, Newton's third law of motion,
Rocket launching.
rocket launching. So here it is given. So you can see how a rocket is launched with the help of third law. Okay, Newton's third law of motion. Any other? Means here in second case, one balloon is shown from which air is just going out. What will happen? That balloon will move in a
Upward.
it will move in a upward direction. Any other example apart from this?
If we throw ball on the wall, ball will come back.
Okay, if you throw the ball, then ball will come back. Okay, any other many more examples are possible in practical. To give examples of Newton's third law.
टाळी वाजवल्यावर लागते आपल्या हाताला सुद्धा.
Okay. Okay, ठीक है. That will be okay. Again, any other? Where you feel it is an example of Newton's third law of motion. Any other? Apply the mind. Apply the mind and try to tell.
When a bullet fire from gun repel backward.
Vishwajit has given correct example. We can say whenever we are going to fire a bullet from gun, what will happen? What will happen? Vishwajit, you have
Gun repel backward.
very good. It will repel backward. Very good. Very nice. Any other example?
बॉल भिंतीला मार.
तेच सांगितलं तुम्ही मराठीत सांगायला लागला त्यांनी इंग्लिश मध्ये सांगितलं होतं. Once we are going to
It will be same act as cannon.
I am unable to listen. Will you repeat?
It will be same act at situation of firing cannon.
Okay, firing cannon. Okay. Any other?
Swimming.
Okay, swimming. Okay. Aeroplane, whether aeroplane will fall under this law of motion? Aeroplane, what the way it is moving in the sky, suppose. Aeroplane, what is the principle of an aeroplane? Aeroplane, whether it will become an example of this, take it as a homework. Aeroplane आपण जाताना बघतो हवेतून. On which basis it is moving forward? म्हणजे त्याला पण कुठला तरी law applicable असेल. Or principle of working of aeroplane. You can search on Google. You can see how it is moving.
Bernoulli's law.
Bernoulli's. Bernoulli's, who told Supriya? You told this? Bernoulli? Okay, any other again? You can search it. Many more examples are possible. A statement is very simple. You can see examples. Many more examples you will find. To every action, there is an equal and opposite reaction. To every action, there is equal and opposite reaction. Okay. A simple way. So launching of rocket, the best example you can keep in your mind. Many more examples will be there.
Newton first law, sir.
Newton's first law. Newton's first law. Okay, Newton's first law. Your opinion is on Newton's first law. Okay, action and reaction. So what it was told, firing of bullet from the gun. Okay, then this action and reaction, action reaction of the ball, it is also for example. Then law of conservation of momentum, total momentum before collision. What is momentum? त्याच्या अगोदर बघूया. Momentum means what? What is momentum?
The product of mass
Product
and
of mass and velocity.
Mass and velocity.
Product of mass and
Velocity.
velocity.
mass and velocity. The product of mass and velocity is called momentum. Actually, in second section of our subject, that is dynamics, all the problems related to this we are going to solve. So what it is, conservation means what? Conservation, law of conservation of momentum. It is very simple. Conservation means conservation, preservation, conservation, keep as it is, we can say. As it is, the total momentum before collision is equal to the total momentum after collision. So in dynamics, actually it is a part of dynamics. In second section we are going to see. So this u is called as initial velocity, and this v is called as final velocity. So that's why this, okay, this one and again this one. Okay, two bodies having mass m1 m2 and having velocity u1 and u2. The total momentum before collision is equal to total momentum after that. That's why it is shown something like this. So in detail we are going to study at the time of dynamics in second section. What is this? Same example is given after that and before that. Once we, objects are going to before and after, what will happen? Momentum, sorry, not moment. Momentum is nothing but product of
Mass and velocity.
mass and velocity. Only that thing you remember now. Further we are going to see. Okay. Now this type equations of motion. This is also part of dynamics. In second section we are going to see. But as it is a prerequisite basic, let us, we are going to here we are going to revising the basic. Okay. So what is this? What you are observing on the screen? What you are observing on the screen?
Equations of
Equation of motion.
Equation of
Motion. Okay, equation. How many equations of motions are there?
three.
three.
Which are they? First one is
Motion equation.
what is that? But what is that equation? V is equal to
U plus AT.
U plus AT.
Initial velocity.
what somebody is telling some extra. What is that? V is equal to U plus AT. What is V? What is V?
Final velocity.
Final velocity.
What is U?
Initial
Initial
velocity.
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 T is an acceleration. T is an
Acceleration T is and time.
Very good. Means all terms are knowing you. What is second equation? What is that?
Displacement.
displacement.
Displacement. U is initial velocity. But what is that equation? S is equal to UT plus
0.
One half
of
AT
Half AT
square.
square.
0.5.
0.5. What is that?
Half AT square.
Half AT square or 0.5 AT square. 0.5 असं म्हणायचं ना. एक तर हाफ तरी म्हणा नाही तर 0.5 तरी म्हणा. S is equal to UT plus 1/2 AT square. Likewise it is called. S is equal to UT plus 1/2 AT square. And what is third equation of motion?
Square is equal to
V square is equal to U square plus twice
Twice
Square is equal
AS.
to U square plus 2AS. Okay, so all these terms now. So what we can find using first equation? Equation
Final velocity.
final velocity. Okay, so we can find final velocity. Is it like that? Final velocity? Okay, your opinion is final velocity. Okay, with this, what we can find?
Displacement.
displacement.
Okay, displacement. Okay, displacement. You are saying displacement. Okay, with this third equation, what we can find?
Final velocity
Acceleration.
square.
Huh? Final velocity? Final velocity? Your opinion is final velocity. If it is like this, then what is the difference between these two? याच्यामध्ये आणि याच्यामध्ये काय फरक?
Square of final velocity.
No. Let it be square, cube, whatever square root. Anyhow, finally, we are going to find velocity itself only, velocity only. Then what will be the difference between equation number 1 and equation number 3?
There is third is for acceleration.
Third is for acceleration. Then that equation might be given in terms of acceleration, no? Whatever v square minus u square divided by 2s. असं दिलं असतं ना, ते असं का दिलं? V square is equal to u square plus 2as. Why it is given in terms of velocity, final velocity again? Then what will be the difference between first equation and third equation? दोन्हीमध्ये जर final velocities मिळत असेल, if at all we are getting final velocity in both the equation, then what is difference?
Given data.
Given data,
In first equation,
Time
time is
and
given.
displacement चा difference येतो दोघात.
काय म्हणताय? What is your opinion?
In first equation, time is given, and in third equation, displacement.
Displacement is given, time is given, and displacement is given. Okay. So actually, what is this first and third? What is the difference between first and third? In both cases, we will get final velocity, but in certain problems, it is told that at any instant of time, the velocity of object can be found out. कुठल्याही दिलेल्या टायमिंगला आपण व्हेलॉसिटी काढू शकतो. कुठल्या इक्वेशन मध्ये काढू शकतो? फर्स्ट का थर्ड? नाउ फॉरगेट अबाउट सेकंड. सेकंड इज एक्सटेंटिव्हली इट इज युज्ड फॉर डिस्प्लेसमेंट. जर डिस्प्लेसमेंट काढायची असेल तर सेकंड बाय डिफॉल्ट, देर इज नो क्वेश्चन. But little there is confusion between 1 and 3 because in both the equations are related to final velocity. Okay, both equations are related to final velocity. Okay, so what is third equation? Actually, third equation is used to get final velocity. Once we are knowing initial velocity and displacement, जर आपल्याला initial velocity and displacement object, displacement means it is final position. Am I correct? एखादी ऑब्जेक्ट एका ठिकाणाहून दुसऱ्या ठिकाणी डिस्प्लेस झालेली आहे. व्हॉट इट मीन्स? फायनल डिस्प्लेसमेंट. तिथून पुढे जाणार नाही आता ते. दॅट्स वाय वी आर सेइंग इट इज डिस्प्लेसमेंट. ओके, दॅट्स वाय व्हेनेवर वी वांट टू कॅल्क्युलेट फायनल वेलॉसिटी, once what it is known to us, initial velocity and displacement, या दोन टर्म ज्यावेळी माहित असतात त्याच्यावेळी फायनल वेलॉसिटी काढायची असेल तर this third equation we have to use. And what is this first then? What is this first? Once we want to know velocity of object at any instant of time, दिलेल्या कुठल्याही टायमिंगला जर आपल्याला इक्वेशनची ऑब्जेक्टची जर मोशन काढायची असेल ऍट एनी इन्स्टंट ऑफ टाइम, कारण टाइम पुन्हा कुठल्या इक्वेशन मध्ये येतो? टाइम फर्स्ट का थर्ड? इन विच इक्वेशन टाइम इज देअर?
First.
That's why that first equation is used to calculate final velocity or velocity at any instant of time. दिलेल्या कुठल्याही टायमिंगला जर आपल्याला त्या ऑब्जेक्टची वेलोसिटी काढायची असेल, इफ यू वांट टू कॅल्क्युलेट द वेलोसिटी ऑफ दॅट ऑब्जेक्ट at any instant of time, we can use first equation. Are you getting the meaning, the importance between these three equations 1, 2, 3? Have you got?
Yes, sir. Yes, sir.
What is the difference between first and third? What is the difference between first and third then?
Sir, in third we can get final velocity, and in first आपण एखाद्या पर्टिक्युलर टाइमची वेलोसिटी काढू शकतो.
टाइमची नाही, एखाद्या ऑब्जेक्टची पर्टिक्युलर टाइमला. You have told correctly, but little sentence formation is different. We can calculate velocity of object at any instant of time. दिलेल्या कुठल्याही टाइमला जर आपल्याला वेलोसिटी काढायची असेल तर कुठली वेलोसिटी काढता येते? फर्स्ट इक्वेशन ने काढता येते. दॅट्स ओके. So I hope up to this, after that we will see. So tomorrow fundamental velocity that we have seen. So tomorrow our core part is going to start. Core part is going to start tomorrow. Resultant revolution. So most important basics almost we have covered. All things basics are covered. So tomorrow with the notebook and with the calculator, you should be there with your notebook, and you should be there with your calculator. So with this we will stop today. Write your numbers in chat box, and if there is any problem, you can ask. Otherwise, we will stop for today. I can understand it is your last lecture.